Hello students, I hope you are all good. In the previous video, we were discussing about instantaneous speed, velocity, initial and final velocity, differentiate between speed and velocity, and types of velocities. In this video, we will learn about uniform motion, non-uniform motion, and acceleration. So let's start the today's video. According to state of motion, motion can be classified in two types. First, uniform motion. Second, non-uniform motion. So let's start with first uniform motion. What is uniform motion? A body is said to be in uniform motion if it travels equal distances in equal intervals of time, no matter how small these time intervals may be. Or motion with uniform velocity is called uniform motion. Example first, a car is running along a straight level highway at steady or constant speed, say 50 km per hour, will cover equal distances of 50 km every hour. So its motion will be uniform. Second example, rotation and revolution of earth is a uniform motion. After that, let's discuss the distance time graph of uniform motion. The distance time graph of uniform motion is shown below. Distance time graph of uniform motion is straight line passing through origin 0, 0. This graph shows that a car is moving with uniform motion and covers 20 km in 10 minutes. Then it covers every next 20 km in every 10 minutes. After that, let's discuss second type, non-uniform motion. What is non-uniform motion? A body is said to be in non-uniform motion if it travels unequal distances in equal intervals of time, or motion with non-uniform velocity is called non-uniform motion. Non-uniform motion is also known as accelerated motion. Example, the motion of a freely falling body is an example of a non-uniform motion. Let's go and discuss the distance time graph of non-uniform motion. The distance time graph of non-uniform motion is given below. The distance time graph of non-uniform motion is curved. This graph shows that a car is moving a distance of 50 km in 1 hour, and in next 1 hour it covers a distance of 40 km. This means that this graph shows a car covers unequal distances in equal intervals of time. After that, let's talk about an important point. Note down this point. Slope of a distance time graph gives average velocity. We will discuss about the slope and graphs in detail in another lecture. After that, let's discuss acceleration. What is acceleration? The rate of change of velocity is known as acceleration. It is represented by small a. Formula of acceleration is equals to change in velocity delta b upon time taken is equals to final velocity small v minus initial velocity small u upon time taken. SI unit of acceleration is meter per second square. Acceleration is a vector quantity. Dimension formula of acceleration is Lt minus 2. Acceleration can be positive, negative, or zero. Positive acceleration means velocity increases with time. Zero acceleration means velocity is uniform or constant. While negative acceleration is called retardation or deceleration, means velocity is decreasing with time. Example, when we accelerate a bike, then it means its velocity is increasing with time. And when we hold the accelerator, then it means acceleration of bike is zero. And bike is moving with uniform velocity. When we apply brakes, then it retards. It means velocity is decreasing with time. If a particle is accelerated for a time t1 with acceleration a1 and for time t2 with acceleration a2, then average acceleration a average is equals to a1 t1 plus a2 t2 upon t1 plus t2. This is the formula of average acceleration.